Hello class, welcome to Unit 7.2, Adding and Subtracting Polynomials. When we are adding and subtracting polynomials, you're going to hear the phrase combining like terms, and that is just saying to add or subtract the coefficients of the terms with the same variable. So what that means is when we look at these problems, we're going to be looking for all of your x's, all of your x squared, all of your x cubed, all of your constants, and we're going to be able to add those numbers together. So when we look down here at example 1, we are looking for like terms. So if I'm starting here, and again, we're going to try to get these into standard form. So I always like to start with the biggest one, which in this case looks like x squared. So what we have here is 4x squared terms. Now, before we kind of jump into anything, we really want to pay attention to this symbol in the middle. Now, if this is a plus symbol, that's going to give us an opportunity to kind of just say, drop those parentheses, because nothing's going to happen. We know with the negative sign, and we'll take a look at some of those with the subtracting, we know we would have to distribute that minus. But really what this is saying is we want to add this whole first term plus this whole second term. So once we establish that they're all plus, now it's a matter of adding those coefficients. So what we're really looking at doing, and I'm just going to kind of write over here on the side, is we're going to be looking at the 14 plus 7 plus 3 minus 2. So if we kind of just take the minute to, do 14 plus 7, which is 21, 21 plus 3 is 24, and then 24 minus 2 is 22. What that's going to tell us is we have 22 x squareds. Now that nothing changes in addition with your x squared variable, and now what we just did is combined all of our x squared terms. Next thing we want to look at here, and sometimes if you're looking at this, it might help to kind of just cross these off, knowing that we used all 4 of those. The next thing is we're going to look for any x terms, which we don't have, and that's only going to leave us with these last 2 constants. So then we're really saying, well, what is a negative 1 plus 3? So 3 minus 1, that's kind of the same deal. What we could say is plus 2, and that is going to be our answer. So then we would simplify. All that would simplify to 22x squared plus 2. When you look at the next example, I'm going to show you another technique. This is going to be stacking them vertically. Some people like to stack them and reorganize everything before you add. Or you could continue to kind of pull them out like I did in example 1. But what this is going to have you do, if we look at adding polynomials and we look at this plus symbol, we are adding this whole term. So we could take a look at organizing these to stack them. So if we had 6a cubed, now they match up. You get 2a squared. Again, just trying to get our like terms together. Plus 4a under the a, and then a minus 7 under the 6. And if we're using what this method is, it's kind of the same thing we did up top. It's just kind of picking out the numbers we wanted. But now what we can do is add everything together, kind of like we were doing with our systems of equations in our elimination method. So negative 3 plus 6, that's going to be 3a cubed. 5 plus 2, that's 7a squared. And then we got a negative a plus 4, so that would be plus 3a. And then we have a 6 minus 7, which would be negative 1. And we have our answer there. Again, it doesn't matter, like I said, if you wanted to kind of stick with what we were doing above, well, then we would kind of say, all right, let's get these 2 together. Oh, negative 3 plus 6. Oh, that gets us straight to our answer. If we get our a squareds together, 5 plus 2, that gives us 7. If we're looking at negative a plus 4a, gets us 3. And then, of course, the 6 minus 7 give us negative 1. So whatever method you use, The important thing here is to make sure that you're only adding like terms and not anything else. So take a look at these next couple examples and give them a shot. All right, good luck. Pause here before we go on and check our answers. So in practice problem number 3, again, you're just kind of matching up our like terms. So we matched them up green, blue, and red, putting them in descending order as we go. Problem number 4, I just rewrote them first underneath in case you wanted just another look at that. Then we add them up, and all we're left with is the negative 5x squared. All right, looking at example 2, we're going to be subtracting polynomials. So now what we can see here is we are going to be subtracting that first term minus the second term. Now the big thing here is, and why we said it's so important with the addition, you don't have to worry too much, but with subtraction, we are subtracting everything. So this is going to be an opportunity for us to use that distributive property. Now, this one I would probably do a little extra encouragement for you to rewrite vertically as you rewrite these, and make sure you're distributing that negative sign each time. So when you distribute to the first one, that becomes negative 3x squared. Negative times a negative, that's going to be a plus 2x squared. And then we are going to have a minus 3. So when we rewrite these, now keep in mind here, both of these were squared as we do them. But as you're kind of rewriting, matching these up, well, that could kind of simplify down here to 11x squared plus 9x squared minus 4. Now, kind of realizing that these are both squared, we could still combine them as like terms and make sure that they are negative 2x squared minus 4. Okay. Looking at example 2, again with our negative sign as you look at solving, which means we are going to subtract everything. So once again, as you go from kind of distributing out that negative sign, I always like rewriting these underneath, because if we're going to distribute and have to rewrite, we might as well help organize as well. So as you're seeing, each one of these positives is turning negative, and now when we do minus a negative, that is going to be a plus 7. And if we take the time to rewrite them, now each one of these terms is going to end up being something we can just add each one and end up with our final answer as we do all those adding and subtracting of our coefficients. So take a second to pause here and finish the rest of them before we move on and check our work. Okay, so take a minute, make sure we're distributing those negatives, make sure we're subtracting every term to get our final answers for 3 and 4. Now, problem number 5, there's nothing really different here. We now have 3, but what you can see here is as we distributed those negatives in the red, kind of lining them up, well, now we're just adding this term. So we could kind of put that plus 12x to the 4 plus 2. And then we're just, again, just trying to add or subtract like terms as we go down each column. Now, that's all wonky, looking all out of place. So remember, our final answer should always be in standard form. So we should see those exponents, 4, 3, 2, 1, constant, and we're good to go. Example 3 is asking us to find the perimeter of each shape. So kind of just blocked off that other one for now. What we are looking at doing is finding the perimeter. Perimeter is just adding up all of your sides. So when we look through them, again, we're looking for like terms. We're going to be adding x's together. In this case, it'll be a 4x minus 2x. So if we do 4x minus 2x, that means that's a plus 2x. We also have another variable in the y. but nothing else for it to match up with, so we're just going to say plus y. And then the third one here, we're looking at adding together all of our constants. So if we have 11 plus 3 is 14, and then 14 minus 8 would be plus 6. So let's get into our pen. There we go. Plus 6. And that would be our final answer. Okay, so once again, looking at these next two, let's start trying to practice a few of these. So again, we're just trying to find those like terms and add it all together, because that's what perimeter is looking for. So pause here and practice these two. So again, as you check your work, make sure we are finding all like terms highlighted in our various colors, and then we're just taking the time to add or subtract them together. As you also practice these rectangles, they're going to work the same way. The only ones that might be a little extra step is, remember, in rectangles, opposite sides are equal. So when we look at the, these first two sides, we had to, understand that they were the same as the opposite. Same thing over here. Well, that looks like a square. Well, then we're going to find out all four sides are the same. But the process ends up the same. Make sure we add up all like terms to get our answer. When we look at example 4 here, let's zoom in on that first one. This one here is a little bit different in what we're looking at, because we have a missing side, but we know what the perimeter is going to be. So what we can do is, start by looking at, let's add the like terms that we do know. We got the x squareds. We also have these x's. So if we look at that, we'll have that 5x squared. We're going to have a plus 9x minus 5, which actually this one here should be green, not blue. So if we know that these two sides totaled the 5x squared plus 9x minus 5, and we know the total was the 5x squared plus 7x plus 12, we know we are going to be looking to take this minus our other total. That will give us that last side. Now remember, this minus means we need to distribute, and then we can look at, subtracting 5x squared. We can subtract 9x, can add the 5. So what we're going to be looking at is 5 minus 5 is 0, 7 minus 9 is negative 2, 12 plus 5 is plus 17, and that is going to be our missing side. Okay, so the same thing is going to work here. Now, the first thing we need to understand is that this is going to be the same. This is going to be the same. Now, we still got our perimeter, so we're still going to start by adding our like terms, because we know that this 10x squared minus 6x plus 4 would be what we know. Now, once again, if this is our total, we are going to subtract our negative 10x squared minus 6x plus 4. And when we do that, we are subtracting all of them. And a minus and negative becomes plus, and minus a positive, we're going to have minus 4. And once we kind of calculate that out, we have that 4x squared plus 10x minus 12. And that becomes our missing sides. Now, careful here, meant to circle that, because that is our combined two sides. Remember, that would represent what both sides equal. If we only want one side, we still need to come back and divide everything by 2. That way we could say, well, 4 divided by 2, 10 divided by 2, and negative 12 divided by 2. Now we have our answer of one side. Okay, let's take a look at some other ones. This problem here is telling us that Bob mowed 2x squared plus 5x minus 3 on Monday, 4x minus 7 yards on Tuesday, and 3x squared plus 10 yards on Wednesday. So how many yards did he mow in the 3 days? All right, this looks a lot like addition here. So we're looking for like terms. Got some x squareds. We got some x's. And we got some constants. So take a second. We're going to add all of those together. 2 plus 3 is 5x squared. 5 plus 4 plus 9x. Negative 3 minus 7 is negative 10 plus 10. Well, negative 10 plus 10 is 0. So right here is our answer. Part B is saying if Bob mowed 14x squared plus 12x minus 3 yards total for the entire week, how many yards did he mow during the rest of the week? Well, this is going to be another one like our perimeter. If we know our total, 14x squared plus 12x minus 3, we know we need to subtract that 5x squared plus 9x to kind of get rid of the 3 days we do know. Now, the reason I'm doing this over here to the side is we know we need to subtract both of these. So when we subtract 5x, when we subtract 9x, there's no constant there. Well, now we can do our subtraction and get our answer. Okay, go ahead and practice the rest of these. So as you solve problem number 2, together, all together, that means add them. And we should come up with negative x plus 30. And how much more money? That's a lot like subtraction. So if we take that 4x plus 10 minus negative 5x plus 20, we can subtract that down there and get our answer. Pause here and solve. So if we know we are looking for the prize of 15x plus 1, and we know we're subtracting out what we already have, make sure we distribute, and then we can combine like terms, and our answer is 7x plus 6. In problem 4, we draw a nice little triangle, do the sides we do know. When we combine those terms, we know that that equals 8a plus b plus 8. Now, if we know the whole perimeter, again, we know we need to subtract what we have. So make sure we distribute. Okay, let's rewrite that. Negative 8a minus 8b minus 8. And that leaves us with 2a minus 5b and plus 4. So again, draw a rectangle. We know two of our sides are 3x plus 4. So we can add them together to get our 6x plus 8. Now, if we know that the perimeter was 10x plus 18, remember, we are subtracting out this total. So we're looking to distribute, rewrite. And what that's going to let us with is a 4x plus 10. Now remember, this is indicating two sides of our rectangle. So we still need to make sure we're dividing everything by 2. So that would be 2x plus 5. And that is going to be our two missing sides. Okay, hope we did okay with our adding and subtracting, a few of our applications. At this point, make sure you have a great day.